Hello everyone. Today we will be learning about the angle between vectors. And no, not that vector we all love from Despicable Me. Alright, quick review. Given two vectors, v equals 2i plus 6j and w equals 10i plus 23j, find the dot product. From the previous lesson, we know that the dot product is equal to AC plus BD. And from that, we can set up our problem as 2 times 10 plus 6 times 23 to get an answer of 158. Before I begin, here are some postulates to keep in mind. The first postulate is that U times V equals V times U, which is to say the commutative property. The next postulate is that U times the addition of V plus W is equal to U times V plus U times W. This is the distributive property. And the third postulate is that 0 times V equals 0, which is the zero property. I'll give you guys a moment to write that down and let it all sink in. Alright, now it's time to do the lesson for the angle between vectors. First, note that there is a difference between the angle between vectors and the direction of a vector. Let me show you how. The direction of a vector is the angle it makes with respect to the x-axis. In this case, because we're using I and j with respect to the positive I-axis. So, say I have a component vector 1, 1. Its direction would be 45 degrees or pi over 4 in radians. Now, say that I have two vectors that start at the origin. One of the vectors v has an endpoint at 1, 3, and the other vector w has an endpoint at 3 root 3, negative 3. When we put those two vectors together, we get an angle. So it is our job in this lesson to find out what the angle is. Without giving you the formula, you can find this angle. So I'll give you a minute to find it. Go. You should have gotten 90 degrees or pi over 4 in radians as your answer mentally. Now, let's move on to the real stuff. Finding the formula. The formula to find the angle between vectors for any vectors is simple. But first, I want to teach you how to find the formula using what you know. Let's say I gave you two vectors, v and w, with the same initial point at A. We know from our fundamental knowledge that the vector v minus w connects them. Now, let's say that the measure of angle A is equal to theta. Now, we can use the law of cosines to help us find theta. Here's how. Upon looking at this at first, you'll find that it's a bit complicated, but in reality, it's just three vectors, and those three vectors are sides, and we're trying to find the measure of angle A, which is theta. So this is basically just another law of cosines problem. Yay, review! Breaking the equation down further using the postulate Angel gave you all, which is that the magnitude of a vector squared is equal to that vector times that vector. In other words, the magnitude of v squared is equal to v times v, which is exactly what is applied here. In order to continue proving our proof, we will continue breaking down the underlying part of the equation, which equals u times u minus u times v minus v times u plus v times v, which results in u times u plus v times v minus 2u times v after collecting like terms. I'm running out of space on this slide, so I'll let you guys copy all that down before I move on. And now we arrive at this. Simple, isn't it? And this is our equation. However, there is one more step we can do. And now you all are finished. I will give you all a moment to copy that down. And now it's time for some examples. The first one being that a vector v equals 2i plus j and the other vector w equals I minus 2j. Your job is to find the angle between those two vectors. Use this formula to help you. You all should have gotten something like this. And you end up getting pi over 2 in radians or 90 degrees. And we'll do a second example where vector v is 10i minus 14j and vector w is 4i minus 22j. I'll give you a moment to solve it. You all should be ending up with a complex figure like this, which simplifies to 7.132 degrees. Thank you all for watching and taking notes. It's been a pleasure teaching you.